Thank you, Keith. Good afternoon, everybody. So this time I'm here speaking not on behalf of the UK IPv6 Council, but of my employer, which is Microsoft IT. That's the internal enterprise networks in Microsoft. I've been with the network infrastructure team there for just over a year. And at the beginning, I must say a disclaimer. There's a difference between the enterprise corporate networks and the online services. Azure, Office 365, Bing, etc. That is a different organization who are my partner that I work with. But don't give me a hard time about their V6 support, because I can relay the message and I'll be very happy to point them to the recording of this session and to your questions. However, they are not under my control. They are my partners. I work with them. So what are we going to cover in the next about 25 minutes? It's first, I would like to tell you a little bit about the network, because some people think that they know Microsoft, but once you get on the inside, you realize how big that organization is and what it actually means from the perspective of IT. Then I would give you a brief overview of our dual-stack deployment. However, the main focus of this talk is really what have we done and how we travel our journey towards IPv6 only. So, from the network perspective, when you look at the whole Microsoft organizations, we are talking about 4 regions. The largest region is in Puget Sound, Redmond, Seattle, state of Washington, where there is a main campus. And there we have got about 100,000 employees. Then we've got other 3 regions. That's how we segment the network: North America, EMEA, and Asia-Pac. In total, IT organization serves about 790, I would say now more like 800 locations globally. So just to get the scope. We have got a mix of on-premise data centers, but in general in Microsoft, in terms of services for the external customers as well as for the internal customers, we are moving our services to Azure. Tail sites or branch offices are connected currently with carrier MPLS. We've got internet peering in the main regions. So we've got peering in Puget Sound, in North America, and a couple of locations, in London and Dublin for EMEA, and we've got then peering in Asia-Pacific regions as well. The AS number that is mentioned behind me is the autonomous system that serves Azure online services, so they are our main peering partner, but we are also working with other service providers to have a backup for our peering connectivity. In terms of employees, if you look at the number of internal employees that IT is serving, is over 113,000. If you add to that the vendors and red badges, we are serving more than 220,000 employees. As IT organization, we have to support more than 1,900 line of business applications. And when we look at about how many devices are hitting our network on a monthly basis, we are looking well over 1.2 million devices. That's obviously not just the end-user devices, those are servers, IoT devices that connect to our network. So this is just to give you an idea what we are trying to manage, the size of the network, the number of our internal customer base, and this is something that we have to consider when we think about IPv6 deployment in such an environment. I would say, from what I've observed for over the years in the UK IPv6 Council, when I worked in Cisco as a systems engineer, I was evangelizing IPv6. And here in this audience, there are many Mohicans of IPv6, that IPv6 deployment is always a story of perseverance. So let me give you a brief overview of what our team has done and when they actually started with IPv6 in the network. So you look now more than 17 years back, in 2001, when Microsoft Research and Development started investigating the protocol because they understood the need to have support for it in the operating system, in the products that Microsoft was delivering to the end customers. So the first way how to quickly deploy it in the network was to use Isotype, where the tunnel brokers were first on Windows servers and then they moved to a hardware platform. I believe that it was Cisco 7200 routers that they used at the time. In 2006, however, there was a significant change. There was Microsoft Windows Vista operating system released, and there was a change in the network stack architecture, where you've got separate services serving IPv4 and IPv6 in the networking stack. The idea behind that was that in the future it will be possible to switch off IPv4, hint for you. What that meant, though, that ISATAP wasn't actually cutting it anymore, because all of a sudden all Vista-enabled laptops and desktops on the network were trying to use IPv6. They were preferring IPv6. So the networking team had to move from using simply only ISATAP on the network to also to support native IPv6 on the network, mostly in the development centers in India, China, and in US. 2011 was a very significant year, in general in the industry as well as for us, because there was World IPv6 Day, which was a test day when we tried to turn on IPv6 globally within the industry and to see whether something breaks or not. Usually it didn't, but then people went and switched it off. However, it was an important milestone. And I would say these dates always help to focus people, to focus the effort and drive the effort. So then actually IPv6 got much higher priority and became a strategic goal, also thanks to these efforts in the industry. You might also recall the famous headlines where IPv6 actually made it to the business newspaper because the price of IP address was set to $11. And that was the Nortel IPv4 address space acquisition. But what I would say, you would think organization as Microsoft and as old as Microsoft would have plenty of public IPv4 space, while majority of it was moved to our Azure online services. And internally, we have moved to RFC 1918. We are using some portion of our public space, obviously, on the edge locations where we have to do NAT44, but we basically had to surrender our IPv4 public space to our online brother. The backbone network was enabled with dual stack, and we moved from running OSPF version 2 in the network to single topology ISIS, because that ensured that we had congruent IPv4 and IPv6 traffic flows. During 2016, the team has enabled IPv6 on the whole corporate network. And within Microsoft IT, there are multiple networks, and I will be talking about them later. All our managed labs also have been enabled with IPv6, so that's the network. We can't force the lab users and the application users and the product groups that are using these labs to deploy IPv6 there, but all the network infrastructure is enabled, because in the end we agree that the network, IPv6 on a network is actually easy. The application is the heart of it, right? But as I said, we've got a corporate network, but there are many other networks under the management of Microsoft IT, and many of them are still IPv4 only. So my team has got our job really cut out. So why are we moving to IPv6 only? What are our motives? First one I would say is industry pressure, which is really a great thing because it makes our internal customers, our product groups, come to my team, Network Infrastructure Services, and saying, we need you to give us an environment in which we can test and make sure that our applications work in IPv6 only environment. So I was very happy in 2015 when I saw the announcement from Apple at the Worldwide Development Conference that they needed from iOS 9 and enforced from iOS 10 that all apps submitted to the App Store have to live in IPv6 only environment. And it might be a surprise to you, but actually there are more than 89 apps that live, Microsoft apps that live on the App Store. I go and count them every 3 months to see what has changed, but it's about this number if you look for Microsoft as a developer in the App Store. So there are quite a few applications that we need to make sure that they are able to live and work in such an environment. And so this is a good reason for us to meet our internal customer requirements. Then also, might be a surprise to you, but we are actually at the bottom of RFC 1918 certainly, because IT has only about 52% of the address space. The 48% we have split with our Azure services, because not only they've got all the public IPv4, but they also need some of the private. So we don't have any /16s of the RFC 19. And for some reason, our product groups think that when they come to us and they ask for allocation, that /16 is the right size of a subnet that they should request. When we ask why, they really don't always know why, but they kind of like that number. So We have to then, my IPAM team has to actually discuss this with them quite a bit, but to figure out what they actually need. But basically, they are using this space to deploy applications and services that live on our internal private part of Azure, because as I said, our services live not only in on-premise data centers, but also in Azure. Then also IoT for us is definitely not a buzzword. We've got smart parking signs, we've got security cameras, printers, smoke detectors, micro-herb greenhouses. Everything lives on our corporate network and consumes address space. So we really are at the bottom, and I will tell you what we are doing about that. We've got then the overlapping space because of the acquisitions, and you would say, for example, that it should be easy to connect on IPv6 between your companies that you are acquiring, but then we find out that some of our internal systems are not dual stack, so we have to do NAT 4.4, and it gets operationally really complex. Operation complexity, talking about that typical problem that we see is our help desk first line support. One of the steps we found out was to tell the user to turn off IPv6, and now things work. Well, they said this is not really a correct troubleshooting step, and then we found out that some policies on firewalls were not set up correctly. They were not the same for v4 and v6, so v6 traffic was getting dropped. Or we deploy some new services, and when we migrate from the old to new, we realized later that the engineer forgot to deploy IPv6 on the new service. So it's actually really operationally quite demanding, and we have to keep monitoring this. So IPv6 only would make sense. This has become a strategic goal for our management, and the reason also why it has become a strategic goal is this, because IPv4 costs a lot of money. The only way how we could get some large blocks of IPv4 is go and spend some of our budget. And I must say I'm really grateful to these meetings, because they are often sponsored by IPv4 Market Group, and the lady, unfortunately I can't remember her name, she's brilliant because she gives us information about how IPv4 price is evolving. And I would like to point out that you see on the table, the price in 2015, before ARIN ran out, was about $7 per IP address in a /16 block, right? So 2015, ARIN ran to the bottom. They don't have any conservation policy like in RIPE and other RIRs. What that means that the price has shot up significantly to what, at least this is the public information, is about $14.50 per IP address in /16 block. That means that I would have to go to my general manager and tell him, you have to spend this much money to get us only 65,000 IPv4 addresses. And I know that he doesn't like that idea and he doesn't want to spend the money, so that's why we need to do v6 only. From the business perspective, from the technical perspective, dual stack is really IPv6 half done, and it's not solving our business problem, having enough IP space for our product groups and enabling our business. So what have we done so far? You might have heard some talks by Microsoft IT at some other events like v6 World Congress, or at the UK IPv6 Council meetings. There were two talks, one in 2015, one in 2016. And there was a presentation about us trying to go and enable wireless guest network as IPv6 only. So what the team wanted to do, they just wanted to see what is going to break. We thought that the application set that needs to be supported on such a network is much easier, it's simpler. This could be actually used by our internal product groups for development, because wireless guests go straight to the internet. If it's v6 only, they can actually simulate the home environment of a network which doesn't provide any v4 and lives behind NAT 6.4. We also thought that it would be easier because there would be fewer SLAs on such a network, and simply we wanted to get exposure and move faster. So whilst we have done some testing on this network, and we also discovered missing features by vendors, etc., we hit a much bigger problem, because this was a plan. And what happens, so on IPv6 network, the news is that you need NAT 6.4 and DNS 6.4. Because if you want to talk to the 80% of the internet which lives in IPv4 only world, you need to have a way how to get to it. The trouble of these technologies is that it breaks the VPN clients. A majority of them actually don't work. There are 2 vendors that I know of, and if there are other vendors who say and can demonstrate that their VPN works in IPv6-only environment and through NAT64, I'll be happy to talk with them. But this issue actually has been documented that unless your VPN client supports NAT traversal during the internet key exchange phase and also encapsulation header IPsec over UDP, you will not get through NAT64. The good news, though, is that we have learned that if your VPN concentrators are v6 enabled, they are dual stack, then you obviously get out natively over IPv6. You avoid the nasty NAT64. What it meant for this project on Wireless Guest, I really couldn't afford to have visitors that come to Microsoft campuses every day complain that they can't connect their VPN client back to their organizations. And they would blame the network that something is broken with us, but actually it's not a problem of the network, it's the fact that they don't have VPN concentrators enabled with IPv6. There are people who are a little bit more militant than us, like Facebook. If you went to their Networking at Scale conference, Paul Sapp would stand up openly say that on the wireless that they provide to the event, that is IPv6 only, and probably majority of the people in the room will not be able to connect on their VPN. And in fairness, you can verify this with Martin Levy, who was at the last conference in May in 2017. He was one of the 2 people out of 600 who actually could connect because his VPN client actually works through NAT64. So I had to stop this project, which was really fun. I was 4 months in my job, so it was a little bit scary. But at the same time, this lesson was really valuable, and we have learned a lot about IPv6 environment. We engaged with our vendors and requested features to be developed for the wireless LAN controllers from security perspective, etc. And so we are now in a phase where we have piloted dual stack on Wireless Guest, and we are going to do a global rollout within these 12 months. What I want to do then, when we've got all the features from the vendors delivered, then I want to start doing something that's called screen test. Basically, we select a location, we switch off IPv4 for a couple of days, we will notify the help desk and tell us how many people actually complain that something breaks for them, and we'll see how that goes. But what have we done? Okay, so Wireless Guest and v6 only is kind of paused for the moment. We are going dual stack there. But how did we fulfill the requirement of our product groups of giving them test environment in which they can verify that their applications work in IPv6 only world and through NAT64? So we have developed a separate IPv6 only SSID for the product groups. It is really something that helps them to meet the industry requirements, like the Apple App Store and US federal government. They are more or less militant when it comes to forcing the vendors to actually really support IPv6. And I'm really grateful for that because they are a real customer. This network provides straight internet path, pure internet connectivity over v6 and goes through NAT64, DNS64. In such an environment, we've got a challenge with Android platform, obviously, because Android is famous for not really thinking much of the IPv6, so we needed to have RDNSS support on our building routers in order to be able to distribute DNS information to the Android users. So at this point in time, we are in progress of upgrading all of our building routers to a version of code that supports RDNSS. We've got some of our building routers are ASR 9000s, we've got ASR 1Ks, and there are some legacy 6500s that are being replaced at this moment. And on ASR 9000, you need at least IOSXR 613 to have this functionality. So we are the upgrades are in progress. Right now, this network is deployed in 11 locations. So less than 8 months ago, we had 0 instances of this network. This network is actually demand-driven by our product groups. Right now, it's Minecraft and Skype and Windows Stack, a group that needs this for testing purposes. And within the next 2-3 months, we will have 6 more locations. And I'm also quite militant when it comes to deploying something and people not using it, right? So I monitor these networks, and if I see that certain location has no users on the network, I'm going to decommission it. At least stop broadcasting the SSID. The infrastructure in the background is still there, but basically, if you are not using it, let's remove it. And you'll be surprised how people react when you tell them you are going to take something away. It's actually quite funny. So What else are we doing? Because I said Microsoft networks are not only corporate network. There's so much more to it. The guest network, VPN, IoT, on-premise data centers that we've got under our control. We've got, obviously, we have to meet security requirements by our InfoSec team. Infrastructure management, that's another chapter. So when I looked at this whole network and all the collection of these networks that we manage, I'm thinking about them all needing IPv6. Not all of them will be IPv6 only in the short to medium term future. Let's start with remote access VPN. So we are in the process of, since the last 8 months, we have been rolling out next generation VPN platform, and that is dual stacked on the inside. If you know how VPN works, you've got the tunnel interface, which can be either v4, v6, but on the inside we've got dual stack. Currently, we've got actually about 50,000 users, so the number is up a little bit. The trouble for me is that the outside of the headends, of the VPN headends, is only IPv4. So right now we are responding only with DNS A record. I want the team to deploy DNS query records, because if you live on a network which treats IPv4 as a service, and these networks are, for example, Charter Communications in North America, Comcast are testing that, Free in France. I, as an enterprise provider, IT provider, have no control over this network over which my users are accessing our resources. And there are things that break, and I have hidden some slides because of the time, but you have them in the slide decks that you can download, which explains the problem with IPv4 as a service and how your VPN can break in such an environment. So I really need our VPN concentrators to be dual stack, and we are in the process of deploying that. And VPN is a big consumer of IPv4 space, and we said, like, we really would like to take that space. If we don't need to use it for internal uses, we can give it to product groups so they can use it for the product development. So at this moment, we are at a point we are doing proof of concept of IPv6 on the inside. So the tunnel interface can be established, the transport can be either v4 or v6, but on the inside, I want only IPv6 because that gives me few /16s back. We can already see in this limited POC that there are already challenges with the OS, operating system, and VPN integration. The network piece, again, is going to be the easy part. But obviously, we are hitting walls, and I'm going to here start with the VPN. So when we started with the POC and we were about to deploy the VPN client profile, we realized that we couldn't actually create the profile without IPv4 subnet. And we went to the vendor and said, like, is it a bug or is it a feature? Unfortunately, it's a missing feature. So we are in the process of requesting IPv6 only VPN profile. So that's something that we need to work on and wait for. Wireless guest and IPv6, we found out that the radius authentication doesn't work over IPv6. It relies on IPv4. Again, going back and trying to work this out with the vendor. Wireless and infrastructure management is quite a closed system, so we thought, okay, let's do something and get our 30,000 access points on IPv6 only, and we can, again, get that little bit of V4 space and give it to somebody who really needs it. And we found out that one of our 2 wireless vendors doesn't support APs dynamically discovering controllers over IPv6. We have to wait for deployment of the next code train, and that's going to take us another 12 to 18 months. So again, we have to wait. This is the wall that we hit, but it's on plan. Internet first in some locations, we are going to do not only the carrier MPLS, but we want to provide local internet breakouts. So the users in those locations who are accessing online services in Azure have better experience rather than going through the hub, let's say South Africa to Dublin and then to the Azure instance. And we found out that IPv6 is again a no-go. Cloud security providers never heard of it, and they secure only 78% of the internet traffic, because 22% of internet traffic today is on IPv6. So that's another one. I would say with v6 only, it's a back to square one déjà vu that people who deployed dual stack 8 to 5 years ago had the same thing. You go and ask, is IPv6 supported? Of course it is. And then you go and look at it properly and you realize it's not. With v6 only, is the same story because there is lots of reliance on IPv4. And yeah, just have to keep pushing. And then just the funny one to conclude this one slide is we've got a certain docking station vendor whose docking stations were causing the PCs to lock up. And they couldn't figure out what was going on. Of course, they blamed the network first. And then they found out that there was this strange thing called router advertisement. And the docking station didn't really expect it. And there was some problem. And we were told, if you are serious about IPv6, you should be doing the IPv6. It's like, well, you can't do without router advertisements on the network because that announces the default gateway, the changes, the mbit, etc. So yeah, they are working on that. So we just keep going, and right now we are in preparation, hopefully only a few weeks away from deploying a proof of concept to one location where the corporate network we switch off IPv4. And we know again the network part is the easy bit. We'll see what's going to break for our users. But we want to do and deploy v6 only on CorpNet because that's the largest consumer of v4 space. We are in the process of getting like proper measurement and visibility into how much v6 traffic versus v4 we've got in the network. So I know in the US, in Puget Sound, we see about 45% of our traffic going to the internet is IPv6. Okay, 45% versus 55%. But I want much bigger visibility. Internet first, there is something more to that. You've got the challenge of multiple IPv6 prefixes. If you are getting v6 from your ISP, and also there is a v6 prefix coming from the CorpNet, how does the endpoint do source address selection? There's a draft that a colleague of mine is involved in, is co-authoring. It's an interesting problem that is worth thinking about. But the important thing is, together with my leadership team, we've decided we need to set a date. No more IPv4. That doesn't mean we switch off IPv4 in all networks. It means that we are at the bottom of the barrel, no more v4, so you really have to do v6. But obviously, we need to engage and communicate with our internal customers and tell them this is coming, you need to get ready. So internal communication is absolutely crucial. Got IPv6 newsletter just telling them what we are doing, and this is not like something that goes out on a monthly basis. I'm not I'm not for sending unnecessary information to people if things don't change. So this is really dependent on how much progress we make. We've also written with my team a position paper which explains the leadership team and the whole management outside the Network Infrastructure Services Organization why we need to do IPv6 only. And this is the operation complexity and the cost of doing IPv4 and dual stack. So again, some tool that helps us to communicate internally. And at the moment, it's a work in progress. I'm working on IPv6 strategy, which tells us how we get to that endpoint. Because if we have a plan, if we build a structure, there is a higher likelihood that we are going to succeed with our efforts. Recognition, that's something that's very important, and I was very pleased when last year Microsoft IT was recognized as one of the IPv6 world leaders in 2017. And behind me you can see a very happy director of our core services team who received the award on behalf of Microsoft IT. And I just want to say, if you are working on IPv6, deploying it in your network, speaking about your efforts is really important, and getting the recognition also justifies the effort that you've put in. So that's possible, and industry is watching how much v6 traffic goes out of your AS, by the way. Here I want to conclude with the Microsoft effect. So this is just a food for thought. I'm not giving you a date yet. But here I want to say that based on the market statistics, 85% of global laptops and desktops are Windows-based. This room is not really a representative sample. I can see lots of Macs here. But then you've got only hundreds of millions of devices like very popular Xbox, HoloLens, various tablets, etc. So the question is, in that networking stack that has separate support for v4 and v6, how long will it make sense for our Windows stack group to support both protocols? That's a question. The next question is how you are going to support your customers, internal or external, in transitioning to IPv6. Okay? So just think about that. The conclusion here. In famous words of Master Oogway from Kung Fu Panda, there are no good or bad news, there are just news. And when it comes to IPv6, it's always, whenever you talk to somebody, Sky, BT here, people from Comcast, Facebook, they would say it's a long story of fighting with the vendors, broken features, missing features, etc. But all of a sudden, when things line up, you will have these sudden victories, and it's definitely worth it. With IPv6 goes saying never give up. That's the only never that you can do. You can never give up. You just have to keep going. It's really hard. It's really easy to get disheartened. And I experience it every day in my job when you just look at something, think it's going to be simple, we can do it, and then you hit an obstacle. But just keep going forward. It is worth it. Talk about your experience and share it with other people, because we are learning from each other, right? And it's only IPv6 only in long term that makes sense. So thank you very much.